Welcome to The Explainer. Every single day, you're absolutely swimming in data. From app ratings to news headlines, it's everywhere. Today, we're going to give you the toolkit to make sense of it all. We're diving into the fundamentals of statistics. So, let's start with a scenario we have all been through, right? You're in an app trying to pick a restaurant. You see it has dozens of 5-star reviews, but then you also see a few just scathing 1-star ratings. So what do? How do you find the truth when the data seems to be telling you two different stories? And that exact moment is when statistics becomes your best friend. It's the science that helps us navigate all this uncertainty, whether we're just choosing where to grab dinner or we're making massive public health decisions like figuring out which strains to include in next year's flu vaccine. So what even is statistics, really? Well, think of it this way. It's the science of managing uncertainty. It's the set of tools we use to collect, analyze, and pull out real, useful information from messy data, all so we can make the smartest choices possible.
All right, let's get into how this actually works. It all starts with two really fundamental building blocks. First up, we've got individuals. Now, in statistics, this doesn't just mean people. It could be the patients in a clinical trial, the hospitals being studied for infection rates, or even different states. And then we have variables. These are just the specific things we measure about those individuals, like a patient's blood pressure or a hospital's infection rate. So these two building blocks, they lead us right to two of the most important concepts in all of statistics: the big difference between a population and a sample.
A population is the whole enchilada. It includes every single member of a group you're interested in studying. So, for example, if your theme is nurses working at Massachusetts General Hospital, the population is the complete list of every single nurse currently employed there.
But let's be real, studying an entire population is often impossible or at least wildly impractical, and that's where a sample comes in to save the day. A sample is just a small, manageable slice of that larger population. So instead of trying to survey every nurse at the hospital, you might just survey the nurses working in the ICU.
So the big takeaway here is this. When you collect data from every single individual, that's called a census. The US Census tries to do this every 10 years. But when you collect data from just some individuals, that's sample data. This is way more common, and we use the power of statistics to make educated guesses or inferences about the entire population, all based on that smaller sample.
And this brings us to a little secret code that statisticians use to keep things straight. A capital N always refers to the total size of the population, while a lowercase n refers to the size of your sample. Simple, I know, but it's super important.
Okay, so we have our population and our sample. Now we need the right language to talk about them. And this isn't just about being picky with words. Trust me, using the wrong term here can lead to some major confusion. Now, here's a simple but really powerful memory trick for you. A parameter is a measurement that describes a population, and a statistic is a measurement that describes a sample. See? P for P, S for S. So the average age of every single person on Medicare, that would be a parameter. But the average age from a phone survey of just some of those people, that's a statistic.
Once you know this, I promise you, you will start hearing this everywhere. A news anchor might say, "The latest unemployment numbers are a terrible statistic for the country." But wait a minute, if they're talking about the whole country, what are they really describing? Yep, a parameter. It might seem like a small thing, but in the world of data, that distinction is huge. So we've defined our population and our sample, but the data we collect from them, well, it's not all the same. We have to classify it, because the type of data you have determines the entire toolkit you're allowed to use for your analysis.
Thankfully, there's a pretty simple process for this. It all boils down to one fundamental question that splits every piece of data you'll ever see into two major types.
And here's the question. Can you calculate a meaningful average of this data? If the answer is yes, like with height or weight, your data is quantitative. It's about quantity. If the answer is no, like with eye color or type of health insurance, your data is qualitative. It's about a quality or a characteristic.
So on that qualitative side, you have nominal data. These are just categories with no natural order, things like types of health insurance. Then you have ordinal data, which has categories that do have a clear order. Cancer stages are a classic example. We all know stage 4 is more severe than stage 1, but the distance between stage 1 and 2 isn't necessarily the same as between 3 and 4. The order is all that matters.
Now for the quantitative side. Here, the differences between the values are meaningful. The key distinction to look for is the 0 point. Interval data has no true zero. For example, the year of a diagnosis.
The year 0 doesn't mean an absence of time, right? But ratio data does have a true 0, where 0 means a complete absence of the thing being measured. Systolic blood pressure is a perfect example. A value of 0 means, well, no blood pressure.
So we've covered a lot: individuals and variables, populations and samples, parameters and statistics, and 4 different ways to classify data. We've built an entire vocabulary. But you might be asking, why does getting all this terminology right actually matter?
Because this is the single most important rule. You can't just use any statistical test on any data. The way you classify your variables dictates which statistical methods are valid. Getting this first step wrong is like trying to use a hammer to turn a screw. It just won't work, and you'll probably break something.
So let's do a quick recap of the core ideas. Statistics gives us a framework for making decisions we're not 100% sure. We study a small sample, little n, to learn about a large population, big N. A number describing that population is a parameter, while a number describing the sample is a statistic. And finally, properly classifying our data as quantitative or qualitative is the essential first step that guides our entire analysis.
Getting these fundamentals right is everything. It's like learning the grammar of data. And once you can speak the language, you can move beyond just reading the numbers and start using them to question the world, challenge assumptions, and find out what's really going on.